Close your eyes for a moment. Let the noise of the world around you fade away. Forget the traffic, the hum of electricity, the voices of people, and the ticking of clocks. Imagine you are rising up, leaving the ground, leaving the atmosphere, and floating into the deepest, darkest black you have ever known. Here there is no up, there is no down, there is only the endless stretching void. It is a place of absolute silence. If you were to scream here, the sound would not travel an inch from your lips. There is no air to carry it. There is only the vacuum, a vast ocean of nothingness that stretches on for billions and billions of miles. It is colder than the coldest winter night you have ever felt. It is a cold so deep that it stops the movement of atoms. It is the temperature of the deep universe resting just above the absolute zero point where all energy ceases to exist. In this quiet, frozen cathedral of space-time feels different. On Earth, time is measured in seconds, minutes and hours. We rush from one moment to the next. But here out in the deep dark, time is measured in eons. 1,000 years is like a blink of an eye. 1,000,000 years is just a short nap. The stars in the distance are not flickering lights. They are steady, unmoving eyes watching the darkness. They are so far away that the light reaching this place left its source before human beings even walked the Earth. For a long time, this part of space was empty. It was just dust and silence. But now something has entered the stage. Out of the obsidian darkness, a shape begins to emerge. It is not a ship made of metal and glass. It is not a creature of flesh and blood. It is a wanderer from the dawn of time. It is an object known to the few who watch the skies as 3E/Atlas. To the naked eye, it looks like a piece of a broken mountain. It is an oblong, jagged rock, roughly the shape of a giant cigar tumbling slowly end over end. Its surface is dark reddish-brown, the colour of dried blood and rusted iron. It is scarred and pitted, carrying the marks of a history we can only guess at. It is not smooth. It is covered in deep cracks and craggy ridges frozen solid by the long journey through the interstellar night. Atlas is a traveller. It does not belong to our solar system. It was born around another star, perhaps a star that died long ago, or one that is still burning brightly in a corner of the galaxy we will never visit. Millions of years ago, through some violent event, a collision of planets or the gravitational kick of a giant gas world, Atlas was thrown out of its home. It was cast adrift, an orphan, in the galaxy. For millions of years it has floated alone. Imagine that loneliness. For centuries upon centuries it drifted through the emptiness between the stars. It passed through clouds of gas where new stars were being born. It sailed through regions of space so empty that not even a single atom of hydrogen touched its surface for 100 years. It has been completely, utterly alone in the dark. It has been sleeping, a frozen stone capsule of ancient secrets tumbling silently through the void. But now the sleep is ending. The journey has brought it here to our neighbourhood. Although it looks peaceful floating there in the dark, the reality of its movement is terrifying. 3I/Atlas is moving with a speed that is difficult for the human mind to truly comprehend. It is tearing through the fabric of space at a velocity of 130,000 miles per hour. Let's try to imagine that speed. A commercial airplane travels at about 550 miles per hour. A bullet fired from a rifle travels at roughly 1,700 miles per hour. Atlas is moving nearly 75 times faster than a bullet. If it were travelling across the surface of the Earth, it could circle the entire planet in minutes. It moves with such ferocity that if it were to hit anything, the energy released would be like 1,000 nuclear weapons going off at once. And yet this creates a strange illusion. If you were floating right next to it watching it glide through space, it would not look like it was moving at all. Because space is so vast and the background stars are so far away, there is no rushing wind to tell you how fast you are going. There is no blur of motion. There is no sound of a roaring engine. There is only the silent, ghostly side of the rock against the velvet black backdrop. It is a paradox. It is a violent screaming speed wrapped in a blanket of total silence. It is moving faster than any machine humanity has ever built, yet it looks as calm as a stone sitting in a garden. As Atlas cuts through the darkness, it begins to feel something new. For millions of years it has felt only the faint, weak tug of distant stars. But now a new gravity is grabbing hold of it. It is the gravity of our sun. To Atlas, the sun is currently just the brightest star in the sky, a piercing point of white light that is growing steadily larger and brighter with every passing hour. The sun is calling it. The massive gravity of our star is pulling this lonely traveller in, bending its path, accelerating it, drawing it out of the interstellar shadows and into the light. The cold that has wrapped Atlas for eons is beginning to shift. It is still freezing, but the radiation from the sun is starting to touch its surface. Deep inside the frozen heart of the rock, the ice is beginning to react. The gases that have been trapped since the birth of its home system are starting to warm up. They are preparing to wake up. This is not just a rock passing by, this is a meeting, this is a greeting from the abyss. The universe is vast and mostly empty, and the chances of this object entering our solar system at this angle, at this speed, at this specific moment in history, are almost zero. It is a cosmic miracle that it's here at all. We are witnessing the end of a very long, silent road. The millions of years of drifting are over. The millions of miles of emptiness are behind it. The climax of its existence is approaching. Imagine you are floating there beside it, matching its incredible speed. You put your hand out, hovering just inches above its rough, dark surface. You can feel the history radiating from it. You can feel the cold. You can feel the sheer weight of the time it has spent traveling to get here. It is a silent messenger bringing news from the other side of the galaxy, though it has no voice to speak. Ahead of it, the solar system waits. The planets Jupiter, Mars, Earth are moving in their orbits, unaware of the Visitul speeding toward their center. The delicate dance of our home system continues ticking like a clockwork mechanism. But the intruder is coming. It is diving down into the gravity well of the sun, falling faster and faster with every second. The silence of space remains unbroken, but the tension is building. The stage is set. The actors are in place, and the vast, empty theatre of the solar system is about to receive its guest. The long wait is finished. The journey across the stars has reached its final chapter. The invisible clock that governs the movement of celestial bodies has started a new count. It is a countdown to the moment of closest approach, the moment when this traveller will brush past the fires of our sun before being thrown back out into the dark forever. The time is now T-minus 18 days. The journey of the interstellar visitor did not begin with a bang, but with a long, silent glide through the abyssal dark. For eons, Oumuamua had existed in a state of profound hibernation, drifting through the void where the temperature hovers just barely above absolute zero. In this realm, atoms hardly vibrate. Time feels suspended. The object was a frozen monument to its own creation, a shard of history locked in the deep freeze of interstellar space. But as it crossed the invisible threshold of our solar system, the silence began to break. This was the beginning of its dance with fire. As the object fell toward the center of our system, it was not merely moving, it was awakening. The transition from the crushing cold of the void to the searing proximity of the sun is one of the most violent environmental shifts a celestial body can endure. Imagine a block of ice that has been preserved in the deepest Antarctic winter for millions of years suddenly being thrown into a blast furnace. This is not just a change in weather, it is a shock to the very molecular structure of the object. In the outer reaches of the solar system, the sun is merely the brightest star in the sky, cold and distant. But as Oumuamua pierced the orbit of Mars and approached Earth's path, the physics of heat transfer took over. In space there is no air to conduct heat, so the object does not warm up like a stone in an oven. Instead, it is a game of radiation. Photons, the particles of light, slammed into the surface of the visitor at the speed of light. When these photons strike, they transfer their energy to the atoms on the surface, causing them to dance violently. The temperature on the sun-facing side of Oumuamua began to skyrocket. We are not talking about a warm summer day. We are talking about a climb from minus 260 degrees Celsius up to temperatures hot enough to melt lead and soften aluminum. This extreme thermal cycling, freezing on the dark side, burning on the light side, creates immense physical stress. The object was tumbling, turning end over end every few hours. This meant that its surface was constantly being whipped between freezing and frying a torture test that would shatter a lesser rock. Yet, Oumuamua held together. This resilience suggests it was likely composed of something distinct, perhaps a rock with a high metal content or a surface baked hard by cosmic radiation over billions of years. This brings us to the most beautiful and chaotic physical process in a comet's life sublimation. In the typical narrative of the cosmos, when a frozen wanderer gets close to a star, it bleeds. Comets are often described as dirty snowballs, mixtures of rock, water, ice, carbon dioxide, and other frozen gases. When sunlight hits them, these ices do not melt into liquid water because in the vacuum of space liquid cannot exist. Instead, the ice transforms instantly from a solid into a gas. This is sublimation. Usually this process is spectacular. The gas bursts outward, dragging dust and pebbles with it, creating a massive glowing halo called a coma and a tail that can stretch for millions of kilometers. This is the hair of the comet flowing in the solar wind. Astronomers waited with bated breath for Oumuamua to display this plumage. They trained their telescopes to look for the fog of water vapor or the shimmer of dust. But here the visitor offered its first great defiance. There was no massive tail, there was no bright cloud of dust. Visually, Oumuamua remained a stubborn point of light, naked and unadorned. It looked like an asteroid, a dry, dead rock, and yet the data told a contradictory story, a story that puzzled the scientific world. Even though we could not see a tail, the object was behaving as if it had one. This leads us to the mystery of the non-gravitational acceleration. In the precise clockwork of the solar system, gravity is the master. If you know the mass of the sun and the speed of an object, you can predict its path with absolute perfection. Gravity pulls and the object curves. It is a simple, elegant equation. However, as Oumuamua swung around the sun and began its exit, it refused to follow the script. It was moving faster than gravity alone could explain. It was being pushed. In the context of a comet, this push is usually caused by the rocket effect. When ice sublimates on the sunlit side of a comet, the gas shoots out into space. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. This jet of gas pushes the comet in the opposite direction. It is nature's own propulsion system. The problem with Oumuamua was the invisibility of this engine. If it was outgassing enough to push a rock the size of a skyscraper, we should have seen the gas, we should have seen the dust, but the space around it was clear. This anomaly forced scientists to propose exotic theories. Was it made of pure nitrogen ice? Nitrogen gas is invisible to many of our telescopes and could explain the push without the visual dust cloud. Or was the object a hollow shell, a light sail pushed by the pressure of sunlight itself? The lack of a visible exhaust plume while the object clearly accelerated remains one of the most tantalizing riddles of the encounter. It was a ghost engine driving the visitor away from us faster than it should have gone. This strange acceleration happened while the object was still relatively far from the sun, which is another curiosity. Usually comets are most active when they are closest to the heat source. But Oumuamua maintained its energy even as it retreated, acting with a vigour that seemed out of place for a dying ember. It was dancing to a rhythm we could not quite hear. Finally, we must look at the stage upon which this dance was performed, the orbit itself. In the study of celestial mechanics, the shape of an orbit is the signature of an object's soul. The planets in our system, Earth, Mars, Jupiter, move in ellipses. An ellipse is a closed loop, it represents belonging. If you are on an elliptical path, you are a prisoner of the sun, destined to return again and again. Oumuamua trace was different. It carved a shape known as a hyperbola. To understand a hyperbola, imagine throwing a ball. If you throw it gently, it curves down and hits the ground in an ellipse. If you could throw it with infinite strength so fast that it escapes the Earth's gravity and never falls back, the path it takes as it shoots away forever is hyperbolic. Oumuamua arrived with a velocity that, astronomically speaking, was screaming. It approached the sun at a speed of nearly 26 kilometers per second while still far out in deep space. This is what scientists call hyperbolic excess velocity. It was moving too fast to be captured. The sun tried to grab it, swinging it around in a sharp hairpin turn, but the visitor's momentum was too great. This specific geometry is the definitive proof that Oumuamua was not born here. It was not a lost asteroid from the belt between Mars and Jupiter. It was not a comet from the Oort cloud at the edge of our system. The eccentricity of its orbit, a number that describes how stretched out the path is, was roughly 1.2. In orbital mechanics, any number roughly equal to 0 is a circle. Any number between 0 and 1 is an ellipse. But a number greater than 1, that means the object is unbound. The hyperbolic trajectory paints a picture of a true wanderer. It means Oumuamua fell down into the gravity well of our sun, accelerated to a peak speed of 87 kilometers per second at its closest approach, called the perihelion, and then used that speed to climb back out of the well. It is a slingshot maneuver, a brief interaction where the object steals a little bit of momentum from the solar system and uses it to fling itself back into the interstellar dark. This orbit tells us that the visit was a one-time event. There will be no return, unlike Halley's comet, which visits us every 76 years like an old friend. Oumuamua is a stranger passing in the night. The geometry of its flight is a line that comes from infinity and goes to infinity, crossing our lives at a single fleeting point. As it survived the fiery embrace of the sun, the melting heat, the structural groaning, the invisible blasts of gas, Oumuamua proved to be a survivor. It took the heat that would have disintegrated a fragile snowball and kept its shape. It took the gravitational pull that holds planets hostage and broke free. It danced with the fire of our star, but it refused to be consumed by it. This encounter was more than just data points on a graph. It was a reminder of the kinetic violence and the silent beauty of the cosmos. We watched a stone or a machine or a shard wake up from a sleep of billions of years, react to the warmth of a foreign star, and then, with a final mysterious push, speed away into the blackness, taking its secrets with it. The physics of the heat, the sublimation and the orbit are well understood, but the specific combination found in this visitor created a masterpiece of ambiguity that we are still trying to decipher. The coffee in the break room at Auburn University had gone cold hours ago, but no one in Dr. Sarah Chen's laboratory noticed. The room was bathed in the soft blue glow of computer monitors, the only source of light in the dark hallway. Outside, the world was asleep, but inside the air was thick with electric tension. Sarah sat hunched over the main terminal, her eyes scanning a graph that looked like a jagged mountain range. To an outsider, it was just a jagged line of white pixels against a black background. But to Sarah, it was a letter written by the universe. They were looking at the atmosphere of a distant exoplanet a world light years away. They couldn't see the planet directly, it was too far and too dim, hidden by the blinding glare of its parent star. Instead, they were looking at the light that passed through the planet's atmosphere. "Zoom in on the near-infrared band," Sarah whispered, her voice raspy from lack of sleep. "Right there, between 1.4 and 1.6 microns. Her colleague, a young postdoctoral researcher named David, tapped the keyboard. The line on the screen stretched out. "Do you see it?" Sarah asked. "The dip." David pointed to a section where the line dropped sharply before rising again. "It's deep, much deeper than the noise floor." This was the magic of spectroscopy, the tool that allowed astronomers to touch the stars without ever leaving the ground. Shutterstock. To understand what Sarah and her team were seeing, you have to understand that light is not just brightness. Light is information. Imagine a beautiful, perfect rainbow. This rainbow contains every colour imaginable, flowing from red to violet. This is the spectrum of a star. However, when that starlight travels through the gas surrounding a planet, something incredible happens. The gas molecules in that atmosphere are like picky eaters. They are hungry for light too, but only for very specific colours. Water vapour likes to eat a specific shade of infrared light. Methane prefers a different shade. Carbon dioxide has its own favourite flavour of light. When the light finally reaches the telescope at Auburn, those specific colours are missing. It is like receiving a rainbow with black vertical bars cutting through it. It is like a barcode at a supermarket. By looking at which thin slices of light are missing the shadows in the rainbow, Sarah could tell exactly what chemicals were floating in the air of a world billions of miles away. These missing pieces of light were the spectres in the spectrum. They were the ghostly fingerprints of matter. "Analysis complete," the computer chimed softly. Sarah held her breath. The screen refreshed, overlaying a reference model on top of their raw data. The fit was perfect. "It's there," she said, leaning back in her chair at a wave of chills running down her spine. "It is undeniable." The first ghost they found was hydroxyl. Hydroxyl is a fascinating, unstable little molecule. In chemical terms, it is simply one atom of oxygen holding hands with one atom of hydrogen. It is not water. Water needs two hydrogens, but it's often the result of water breaking down. "Hydroxyl," David breathed out. "That means starlight is hitting water vapour high in the atmosphere and smashing it apart. Finding hydroxyl was like finding smoke. It strongly suggested that there was a fire, or in this case water, somewhere nearby. It was a chemical signpost pointing toward a wet world. But hydroxyl is also aggressive. It reacts with everything. It is often called the detergent of the atmosphere because it scrubs away other chemicals. Seeing it so clearly meant the chemistry on this planet was active, dynamic, and alive in a geological sense. But the story the light was telling them did not stop there. "Look at the shoulder of the graph," Sarah directed, pointing to a different section of the spectrum further to the right. "There is another shadow." This absorption line was wider, heavier. It commanded presence. "Carbon dioxide," Sarah confirmed. "Carbon dioxide. One atom of carbon flanked by two atoms of oxygen. On Earth, we often think of it in the context of climate change, a gas that traps heat. But for an astronomer hunting for Earth-like worlds, carbon dioxide is a treasure. "It is highly concentrated," David observed, typing notes furiously. "This is good," Sarah said, her mind racing through the implications. "A planet needs a blanket. If there is enough carbon dioxide, it suggests a greenhouse effect. It means the planet might be warm enough to keep water liquid on the surface rather than freezing into ice. Furthermore, finding carbon dioxide in such quantities hinted at a rocky world with volcanoes. Volcanoes are the engines that pump carbon from the inside of a planet out into the atmosphere. It suggested a carbon cycle, a planetary heartbeat that moves elements from the ground to the air and back again. For a moment, the room fell silent. The team just stared at the screen. It's a profound feeling to realize that the jagged line on a monitor is actually a weather report for an alien world. Sarah closed her eyes and imagined the planet. Because of the hydroxyl, she imagined thin, wispy clouds high in the sky being blasted by the radiation of the star. Because of the carbon dioxide, she imagined a thick, heavy air, perhaps a sky that wasn't blue, but a hazy, warm white or orange. She imagined the warmth trapped near the surface. "It's not a dead rock," Sarah whispered. "It's breathing in." It was breathing. This is the true beauty of spectroscopy. It turns the invisible into the visible. Our human eyes are limited. We evolved to see a tiny sliver of reality, the colours of a ripe fruit or the movement of a predator in the grass. We cannot see infrared, we cannot see ultraviolet, we cannot see the vibration of a carbon dioxide molecule. But with these instruments we can expand our vision. We can read the history of the universe written in the language of light. "We need to confirm the ratio," David said, breaking the reverie. "If the ratio of carbon to oxygen is low, it confirms a terrestrial origin. If it is high..." "I know," Sarah said, standing up and walking to the window. She looked up at the night sky. Somewhere up there, hidden in the darkness, was the source of that light. The spectres in the spectrum had spoken. They had told the team that the planet had the ingredients for complexity. It had the detergent to scrub the sky and the blanket to keep it warm. "We aren't just looking at chemistry," Sarah said, turning back to her team, a small tired smile playing on her lips. "We are looking at potential. We are looking at a stage that is set for something to happen." The light had travelled for millions of years, carrying these secrets across the cold void of space. It had passed through dust clouds and solar winds, preserving its message until it hit the mirrors of their telescope. Sarah touched the screen, tracing the dip of the carbon dioxide line. "Save the data," she ordered, "and get the coffee pot running again. We have a lot of work to do. We need to look for the next ghost." "Methane?" David asked. "Maybe," Sarah replied. "Or maybe something even stranger. The spectres were there, hiding in the rainbow, just waiting to be found." High above the atmosphere in the velvet silence of the vacuum, the sentinels were already awake. They do not sleep. They do not blink. While the cities below moved through their chaotic cycles of day and night traffic and commerce, the great mechanical eyes of humanity remained fixed on the burning heart of the solar system. This was not the work of a single nation or a solitary scientist. It was a global chorus of glass, gold and radio waves singing a song of vigilance across millions of kilometers of emptiness. Far beyond the orbit of the Moon, the James Webb Space Telescope floated in its cold, lonely outpost at Lagrange Point 2. It sat with its back to the sun, protected by a tennis court-sized shield that kept its sensitive instruments at temperatures hundreds of degrees below zero. Usually its golden honeycomb mirrors were turned toward the dawn of time hunting for the first galaxies born after the Big Bang. But today its schedule had changed. The commands had rippled out from the control center in Maryland, travelling through the void to whisper into the telescope's receiver. The great golden eye shifted. It did not look directly at the sun that would destroy it, but it turned its attention to the effects monitoring the planetary atmospheres and the background wash of radiation in the solar system. It was watching the dust of the cosmos dance to the magnetic rhythm of the coming storm. Closer to home, the Hubble Space Telescope, the old veteran of the stars, continued its low Earth orbit. It had watched the universe for over 30 years. It had seen comets crash into Jupiter and stars explode in distant galaxies. Now it served as the near guard. Its gyroscope wheels spun silently, stabilizing the tube as it captured images of the auroras erupting on the poles of Saturn and Jupiter. Early warning signs that the solar wind was picking up speed, affecting not just Earth but the entire neighborhood. Hubble was the reliable grandfather, the steady hand that had seen it all before, sending down packets of data that said, "I see it. It is coming." But the bravest of the all was the Parker solar probe. Millions of kilometers closer to the star, diving into the corona itself, Parker was touching the fire. It was a tiny machine, smaller than a car, flying at speeds that were difficult for the human mind to comprehend, hundreds of thousands of kilometers per hour. It faced the full unblinking rage of the sun. Its thick heat shield, a marvel of carbon foam, glowed white-hot, holding back temperatures of over 1,000 degrees Celsius. Behind that shield, the instrument stayed cool, measuring the magnetic fields and the flow of particles at the very source. Parker was the scout in the enemy camp. It tasted the solar wind before it even had a chance to cool down. It sent back the most crucial message of all: the density, the speed, and the magnetic orientation of the blast. It was screaming into the radio void, telling Earth exactly how hard the punch would be. On the surface of the Earth, the atmosphere was different. It was not cold and empty, it was heavy with oxygen, coffee and anxiety. In the control room of the Space Telescope Science Institute in Maryland, the lights were dimmed to a soft blue. It was a clean silence. There was no shouting, no running, no dramatic throwing of papers. The drama here was internal. It was a room filled with rows of glowing monitors and the soft, rhythmic clicking of keyboards. The air conditioning hummed a low, steady bass note that seemed to underline the tension. Dr. Aris Thorne stood behind the main flight dynamics console. He held a paper cup of coffee that had gone cold an hour ago. He didn't drink it, he just held it, a grounding object in a world of abstract numbers. On the giant screen at the front of the room, a complex visualization of the solar system was displayed. Green lines represented the orbits of the planets. Red waves represented the incoming coronal mass ejection. The room was filled with the best minds from 3 continents physically present or connected via secure video links. They were the pilots of machines they could not touch. They were flying spacecraft located 1.5 million kilometers away by typing commands into a terminal. Telemetry from Parker is solid, a flight controller said. Her voice was calm, practiced. Particle density is rising. It matches the predictive models from the simulation. Thank you, Sarah, Aris replied softly. The quiet in the room was heavy. It was the silence of a hunter waiting in a blind or a captain on the bridge of a ship, watching a rogue wave rise above the bow. It was a unique human emotion, the anticipation of the sublime. They were not just afraid of the damage the storm might cause to the power grids or satellites. They were in awe of the physics. They were watching a star breathe. They were watching the engine of life roar. Thousands of kilometers away in the high desert of the Atacama in Chile, the air was thin and dry. Here stood ALMA, the Atacama Large Millimeter Array. 66 giant radio antennas, white dishes looking like strange mushrooms, were scattered across the plateau. They were not looking at light, they were listening to the invisible. They moved in perfect unison, turning their heavy white heads toward the sun. The mechanical groan of their gears was the only sound in the desolate red landscape. Inside the control building at the darkest edge of the desert, the team was analysing the radio frequencies coming from the sun's surface. The sun was screaming in radio waves, a chaotic noise that only ALMA could decipher. The active region is pulsing, a technician said in Spanish, his eyes darting across a waterfall of data on his screen. The magnetic loops are twisting again. We are seeing a secondary flare. The data from Chile zipped through fibre optic cables under the ocean, bouncing off relay satellites and appearing on Aris Thorne's screen in Maryland less than a second later. This was the true miracle. It was not just the storm, it was the net. Humanity had built a nervous system for the planet. The eyes were in space, the ears were in the desert, and the brain was distributed across dozens of laboratories. A scientist in Tokyo could see the data from a probe near Venus at the same time as a researcher in Berlin. Aris looked around the room. He saw a young trajectory analyst rubbing her temples, her eyes tired but focused. He saw the mission director speaking quietly into a headset, coordinating with the Deep Space Network in Australia to ensure they didn't lose the signal as the Earth rotated. There was a profound sense of connection in this vigil. Usually humans feel small when they look at the universe. The sheer scale of the black void, the billions of light years, the fusion power of the stars, it makes a human life seem like a speck of dust. But in this control room, surrounded by the hum of servers and the glow of screens, the feeling was different. Technology had built a bridge. By understanding the storm, they were no longer just victims of it. They were participants. They had reached out their hand to touch the sun. They had built glass eyes to see the invisible. They had used mathematics, a language invented by human brains, to predict the behavior of a ball of gas 150 million kilometers away. 3 hours to impact, the voice came over the intercom. The tension ratcheted up one notch, but it remained a quiet tension. People sat up straighter. The clicking of keyboards sped up slightly. Aris finally took a sip of his cold coffee. He grimaced but swallowed it. He looked at the main screen where the red wave of the simulation was inching closer to the blue dot of Earth. He didn't feel panic. He felt a strange, deep reassurance. Out there, Parker was enduring the heat. Hubble was holding steady. The dishes in the desert were listening. The network was holding. Humanity was awake. They were standing guard, a global tribe watching the fire in the dark. No matter what happened when the wave hit, they would see it coming. They would measure it. They would understand it. And in that understanding, there was a victory that no solar storm could take away. The room settled into the final wait. The only sound was the hum of the machines, the heartbeat of the global vigil steady and strong against the approaching thunder. October 29th, 25. This is the day of the crossing. This is the moment the traveller known as 3i Atlas faces the ultimate test. For millions of years it has floated in the frozen silence of the outer dark, a sleeping mountain of dirty ice and ancient dust. But now that long sleep is violently over, we are no longer watching from a distance. Imagine we are right there riding alongside the comet, witnessing the cosmic forge at work. The first thing you notice is that there is no sky anymore. There is only the sun. It dominates everything. It is no longer a friendly yellow coin in the blue sky. It is a wall of blinding, terrorizing white fire. It stretches above and below, filling the entire field of vision. The light is so intense that it feels like it has physical weight pressing down on the comet's surface with the force of a heavy hand. We are entering the perihelion, the point of closest approach. The pacing of the universe seems to slow down here. Even though the comet is moving at incredible speeds, hundreds of thousands of kilometers per hour, the sheer scale of the sun makes the movement look like a slow, majestic drift. This is a ballet of destruction. As Atlas plunges deeper into the solar corona, the invisible atmosphere of the sun, the violence begins. It starts with the solar wind. This is not a wind of air, but a relentless storm of charged particles, protons and electrons moving at nearly the speed of light. When this solar hurricane hits the comet, it does not just blow past, it strikes like a hammer hitting an anvil. You can see the impact. The front of the comet, the side facing the sun, begins to glow with a fierce blue-white intensity. This is the bow shock. It looks like the wave created by a ship moving through water, but this wave is made of plasma and magnetic energy. The solar wind is stripping away layers of the comet's atmosphere, tearing electrons from their atoms, creating a chaotic glowing shield that tries desperately to protect the ice beneath. Now look closer at the surface of the comet. For eons, this surface was colder than the deepest winter on Earth. Now within hours, the temperature swings to hundreds of degrees. The solid ground is not melting, it is sublimating. That means the ice turns instantly into gas, skipping the liquid stage entirely. It is an explosion in slow motion. Great jets of gas erupt from the dark crust. These are not gentle puffs of steam, they are geysers the size of skyscrapers. They blast outward with the force of jet engines carrying tons of dust and rock with them. These jets act like thrusters, pushing the comet, making it spin and tumble in unpredictable ways. The structure of Atlas begins to groan. If there were air to carry sound, the noise would be deafening. It would sound like the cracking of 1,000 glaciers mixed with the roar of a rocket launch. Deep inside the comet, the heat is trying to penetrate the cold heart. The thermal stress is unbearable. The rock and ice expand at different rates. Crack! A fissure opens up on the equator of the comet. It moves slowly like a zipper, undoing the fabric of a mountain. A piece of the comet, perhaps the size of a football stadium, detaches. In the low gravity, it floats away gently, tumbling in silence. But as soon as it exposes its fresh, icy interior to the sun, it flashes into vapor. One moment it is a rock. The next, it is a brilliant cloud of gas adding to the growing tail that stretches out behind the comet for millions of kilometers. This is the forge. The sun is hammering the comet, burning away the impurities, reshaping it. The weak parts are destroyed, only the dense core remains. But there is another force at work here, one that is invisible to the eye but violent to the senses: magnetism. The sun is a giant magnet, and its magnetic field lines are twisted and tangled. As the comet flies through these invisible ropes of magnetic force, it creates a disturbance. The plasma around the comet twists and snaps. This interaction creates a magnetic singing. Close your eyes and imagine the sound of this electromagnetic storm. It is not a human sound. It starts as a low rhythmic thrumming, like a heavy heartbeat: thump, 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 thump. This is the pulse of the solar wind slamming against the comet's magnetic bubble. Then, as the pressure builds, the sound rises. It becomes a screaming whistle, like a kettle boiling over, but layered with the static hiss of a broken radio. It is the sound of ions screaming as they are ripped away into deep space. Occasionally there is a sharp snap, like a whip cracking, as magnetic field lines break and reconnect, releasing bursts of energy that light up the coma in flashes of violet and green. It is a symphony of chaos, a song of fire and ice. The comet is now at the very peak of the curve. This is the moment of maximum danger. The gravitational pull of the sun is trying to tear the comet apart, pulling the front harder than the back. This is called the tidal force. The comet stretches, groaning under the strain. Will it survive? For a few breathless minutes, it seems the comet might simply evaporate, turning entirely into a ghost of gas. The coma, the cloud of gas surrounding the nucleus, becomes so bright that it rivals the planets in the night sky. It is a glowing green eye, looking into the face of a god. Inside the dust tail, a transformation is happening. The intense heat is baking the dust grains, changing their chemistry. This is the same process that happened at the birth of the solar system. We are watching the history of creation repeat itself in real time. The dust that lifts off Atlas today will eventually drift through the solar system. Some of it might land on Earth as shooting stars, some might become part of other planets. The comet is sacrificing itself to seed the universe with new material. As the minutes pass, the worst of the heat begins to fade just slightly. The comet has passed the closest point. It has survived the hammer blow. It is smaller now, scarred and changed. Its surface is unrecognizable, reshaped by the violent sublimation. It has lost millions of tons of mass in just a few hours. The jets of gas are still firing, but the rhythm is changing. The scream of the magnetic storm lowers to a dull roar. The blinding wall of white fire begins to recede, curving away behind the traveller. Arched Atlas emerges from the other side of the sun. It is no longer just a rock, it is a survivor. It leaves behind a trail of glittering debris, a glowing scar in the solar system that will linger for weeks. It has touched the fire and lived to tell the tale. The slow-motion violence settles down, returning to the cold, quiet drift of space travel. But the comet is forever changed. It has been forged in the heat, and now it carries the story of our sun back out into the endless dark. The roaring fire of the sun is now behind us. The sensors which were locked down tight to survive the intense heat have finally opened again. We are drifting in the quiet, cool shadow of the star, a place where the chaotic winds of the solar atmosphere begin to calm down. It is here in this silent wake that we deploy the collectors. We are not looking for fire anymore. We are looking for ash. We are looking for the dust that the sun has been protecting for billions of years. When the first samples arrive in the analysis chamber, they do not look like much. To the naked eye, they appear as nothing more than specks of soot, the kind you might flick off a bookshelf without a second thought. But as the microscopes focus and the mass spectrometers begin their work, the true nature of these specks is revealed. We have stumbled upon the ancient library. These are not ordinary particles. They are what scientists call pre-solar grains. The name itself gives a hint of their majesty. These are tiny bits of matter that existed before our sun was born. They are older than the Earth, older than the Moon, and older than the solar system itself. As the instruments analyze the chemical makeup, the data confirm something staggering. The isotopic signatures, the specific fingerprints of the atoms inside these grains, tell us that they were formed approximately 7 billion years ago. To put that in perspective, our solar system is only about 4.5 billion years old. These tiny grains have been floating in the dark void for 2.5 billion years before they ever found a home near our sun. They are travelers from a time deep in the forgotten past. They are made of silicon carbide and tiny diamonds hard enough to survive the violent birth of our star and the harsh radiation of deep space. But the hard minerals are not the most shocking discovery. As we dig deeper into the chemical structure of this dust, the analyzers detect something else, something that makes the entire crew hold their breath. Wrapped inside these ancient shells of carbon and silicon protected from the ravages of time are complex organic compounds. We find amino acids. Amino acids are often called the building blocks of life. They are the fundamental components that make up proteins, which in turn make up the cells of every living thing on Earth, from the bacteria in the soil to the humans piloting this ship. Finding them here inside dust that is 7 billion years old changes everything we thought we knew about our origins. For a long time, humanity believed that the ingredients for life were cooked up specifically on Earth, perhaps in a warm, muddy pond struck by lightning. But this discovery suggests a different story. It suggests that the recipe for life was written long before the Earth even existed. The universe was brewing the ingredients for biology in the vast cold clouds between the stars. This brings us to the connection between death and life. These pre-solar grains are the leftovers of ancient stars that died long ago. When a massive star reaches the end of its life, it does not simply fade away, it explodes or puffs off its outer layers, sending massive clouds of gas and dust out into the galaxy. These dying stars are cosmic kitchens. Inside their burning cores, they fuse simple atoms like hydrogen and helium into heavier elements like carbon, oxygen, and nitrogen. When those ancient stars died 7 billion years ago, they ejected these elements into the void. As the hot gas cooled down, it condensed into solid grains, the very grains we are looking at now. Over millions of years, these grains drifted through the galaxy like seeds carried by the wind. Eventually, they clumped together in a giant molecular cloud which collapsed under gravity to form our sun and its planets. This means that the carbon in our bodies, the oxygen we breathe, and the iron in our blood are not local inventions. They are heirlooms. We are walking, talking monuments to stars that burned out billions of years before the first human opened their eyes. This realization forces a profound philosophical shift in how we view ourselves. We often think of life as something fragile and rare, a lucky accident that happened on one blue marble in a vast empty dark. But if the building blocks of life, these 7 billion-year-old amino acids, are floating everywhere in the dust of the galaxy, then perhaps life is not an accident. Perhaps it is an inevitability. The universe seems to be wired to create life. It creates the seeds in the bellies of dying stars and scatters them across the cosmos, waiting for them to land on a fertile world like Earth. Holding these data points is like holding a history book written by the universe itself. Each grain of dust is a page in that book. It tells the story of a red giant star that swelled up and died eons ago. It tells the story of the cold, lonely journey through interstellar space. It tells the story of how that dust survived the fiery birth of our own sun. It forces us to rethink the concept of time. We usually view time as a straight line moving from the past to the future. But in these grains, the past is physically present. The death of a star 7 billion years ago is directly linked to the hand that holds the coffee cup on the ship's bridge today. The matter is the same, only the form has changed. The destruction of that ancient star was necessary for our creation. Without that death, there would be no carbon to build our cells, no oxygen to fill our lungs. There is a beautiful, haunting symmetry to it. To create the future, the past must be broken down and reshaped. We are the afterlife of stars. When we look at these pre-solar grains, we are looking at our ancestors. Not our biological ancestors like monkeys or fish, but our atomic ancestors. This discovery also dissolves the feeling of isolation that often comes with space travel. When you look out the window into the black abyss, it is easy to feel small and alone. But the ancient library tells us that we are chemically connected to the entire cosmos. We are not strangers in the universe. We are its children. We are made of the same star stuff that swirls in the great nebulas and lights up the distant galaxies. The presence of these organic compounds suggests that the universe is not a cold, dead place, but a place waiting to wake up. It suggests that the potential for consciousness is woven into the very fabric of matter. If these amino acids could survive for 7 billion years in the harsh vacuum of space, protected only by a shell of carbon dust, it implies a resilience to life that is hard to comprehend. It implies that life wants to exist. As we catalogue these grains, naming them and mapping their structures, we realize we are reading the oldest story ever told. It is a story of recycling on a cosmic scale. Nothing is ever truly lost. The energy of a supernova becomes the beating of a human heart. The dust of a dead solar system becomes the soil of a new world. We are drifting through a library of potential. Every speck of dust hitting the hull of our ship carries the code for life waiting for the right conditions to unfold. It makes the universe feel less like a vast empty room and more like a garden in winter dormant perhaps, but filled with seeds that are sleeping beneath the snow, waiting for the spring of a new sun to wake them up. The journey through the sun was terrifying, a battle against fire and fury. But this quiet aftermath sifting through the ashes of creation is perhaps even more overwhelming. It is a spiritual encounter with the deep time of the cosmos. We have found the bridge between the inorganic and the organic, between the stone and the flesh, between the dying past and the living present, and we found it in a handful of dust. Only a few months ago, the comet had been fighting for its life inside the scorching atmosphere of the star. It had endured temperatures that could melt steel. It had been pulled and twisted by gravity tides so strong they threatened to rip its nucleus apart. But now, as the calendar on distant Earth turned toward the end of the year 2024, the comet was drifting outward. It was wounded, cracked, and shedding dust, but it was alive. The blinding white wall of light that had dominated its existence was shrinking behind it, slowly transforming back into a defined circle rather than an all-consuming fire. The journey outward was very different from the journey inward. When it had approached the sun, the comet was full of anticipation and growing energy. It was waking up. Now it was like a tired traveller leaving a loud, chaotic city and heading back into the quiet wilderness. The noise of the solar wind, which roared with charged particles, began to quiet down. The magnetic storms that had danced across its surface smoothed out. Throughout the year 2025, the comet sailed through the silence. This was the great empty between the inner planets and the outer giants. It crossed the region known as the asteroid belt, but space is so incredibly vast that it did not see any fields of floating rocks. It was alone. The comet was a tiny speck of ice and dust suspended in a darkness that stretched on forever. The tail, which had been a magnificent banner of gas and dust stretching for millions of kilometers, began to weaken. Without the intense pressure of the sunlight to push it, the tail became thinner, more ghostly. The violent geysers of steam on the surface of the nucleus sputtered and died. The crust, which had been soft and shifting, began to freeze solid again. The comet was sealing its own wounds, preparing for the cold that was to come. But there was one last appointment to keep, one final meeting before the eternal night. Ahead of the comet, a bright star was growing larger with every passing week. It was not a star, but a world. It was Jupiter, the king of the planets. By early 2026, Jupiter was no longer just a point of light. It was a small disk. By March of 2026, it dominated the sky. To understand the scale of this encounter, one must realize that Jupiter is a monster. It is so massive that it could hold 1,300 Earths inside it. It is so heavy that it does not just sit in space, it bends the fabric of space around it, creating a deep gravity well that pulls everything nearby toward it. The comet was falling into this well. The encounter was terrifying in its beauty. As the comet raced closer, the details of the giant planet became visible. It was a world of clouds painted in stripes of cream-burnt orange and brown. These were not peaceful clouds, they were violent storms that had been raging for centuries. The winds there blew at speeds of hundreds of kilometers per hour. Dominating the southern hemisphere was the Great Red Spot, a storm so wide that the entire planet Earth could fit inside it with room to spare. It watched the comet like a giant unblinking crimson eye. The comet could feel Jupiter before it arrived. The planet possesses a magnetic field of immense power, thousands of times stronger than that of Earth. As the comet entered this invisible web, the remaining charged particles around it began to glow and twist. The radiation environment was intense, a crackling energy that sizzled against the icy skin of the traveller. Then came the gravity assist. In the laws of orbital mechanics, this is a dance of theft. The comet was not just flying past Jupiter, it was stealing from it. As it swung close to the planet, the massive gravity of Jupiter grabbed hold of the tiny comet and whipped it around. The speed was incomprehensible. Relative to the planet, the comet was moving at tens of thousands of kilometers per hour. It swung around the dark side of Jupiter, plunging into a shadow that was deeper and colder than anything it had felt near Earth. For a few hours, the sun was completely blocked out by the massive bulk of the planet. The comet flew in total darkness with only the faint, ghostly glow of lightning, storms deep within Jupiter's clouds to light the way below. Above the great icy moons, Europa, Ganymede, Callisto hung like silent pearls watching the intruder pass. This moment changed everything. Until this point, the comet had been a prisoner of the sun. Like the Earth, Mars, and all the other planets, it was trapped in an elliptical orbit. This means its path was a closed loop. If left alone, it would eventually slow down, turn around, and fall back toward the sun in a few thousand years. It was tethered like a dog on a very long chain. But Jupiter broke the chain. The gravity of the giant planet gave the comet a massive kick, transferred a tiny, unmeasurable amount of its own momentum to the comet. Jupiter slowed down in its orbit by less than the width of a single atom, but that energy when given to the tiny comet was enormous. The comet accelerated. It gained so much speed that it achieved what scientists call escape velocity. The shape of its orbit snapped. The closed loop of the ellipse broke open and became a hyperbola. A hyperbola is an open curve. It does not return. It is a line that goes out and out and out forever. As the comet shot out from behind Jupiter back into the weak sunlight, it was moving faster than it had ever moved in the outer solar system. It was no longer just a traveller, it was an exile. The departure was long and slow. The human mind struggles to understand the patience of the cosmos. The year 2026 ended, and the comet was still racing away. 2027 passed in silence. The sun, which had once been a terrifying furnace, was now just a very bright star. It provided no warmth. The temperature on the comet dropped to minus 240 degrees Celsius. It was a frozen stone, once again silent and dead. It crossed the orbit of Saturn, the ringed jewel of the solar system. From this distance, Saturn was just a golden spark. The comet did not stop. It passed the orbit of Uranus, the ice giant that rolls on its side. It passed the orbit of Neptune, the blue sentinel that guards the gates of the system. With every million kilometers, the sun grew smaller. The gravity that had held the comet for 4.5 billion years was weakening. The invisible tether was stretched until it snapped. There is a profound sadness in a hyperbolic trajectory. Most comets are faithful. They leave, but they promise to return. Halley's comet will return. The great comet of the 19th century will return. They have a home. They have a cycle. But Comet C2024S1 had no schedule anymore. It was leaving home and it was never coming back. As the decades turn into centuries, the comet will cross the heliopause. This is the boundary where the wind from the sun finally dies out and meets the cold interstellar wind of the galaxy. Here the comet will enter the true void. In this realm, the stars do not twinkle. They burn with a hard, steady, cold light. The distance to the nearest star is not measured in kilometers, but in light years. The darkness is absolute. The comet carries with it the history of the solar system. Deep inside its frozen layers, it holds dust from the birth of the sun. It holds the scars of its encounter with the solar fire. It holds the memory of the blue planet where creatures of flesh and blood looked up and marveled at its beauty. But there will be no one to read this history. The comet is a message in a bottle cast into the infinite ocean of the Milky Way with no shore to wash up on. It will travel for 10,000 years and it will not reach another star. It will travel for 1,000,000 years and it might still be drifting in the empty spaces between solar systems. It has become a ghost, a wanderer in the cathedral of the cosmos. The sun is now just one star among billions. The connection is severed, the journey has no end. The comet had touched the fire, it had danced with the giant, and now finally it belonged to the eternal night. It was gone. The telescope lenses have finally cooled down. The screens that once flashed with data and excitement have dimmed to a soft, sleeping grey. The great traveller, the object we called 3i Atlas, has moved beyond the reach of our eyes. It has slipped back into the velvet curtain of the deep dark, returning to the silence from which it came. But as it fades into the endless night, it leaves behind something far more permanent than a trail of dust or a reflection of sunlight. It leaves us with a feeling, a new understanding that has settled in our hearts like a warm, heavy blanket. For so long we looked up at the night sky and saw a lonely place. We saw vast distances that seemed impossible to cross. We saw a cold, empty void where we were the only ones watching, the only ones breathing. But Atlas changed the shape of that emptiness. By passing through our solar system, by drifting close enough for us to see its red and weathered skin, it turned the lights on in a dark room. It showed us that the space between the stars is not empty at all. It is a bridge. It is a highway. It is a garden full of wandering stones and ancient ice, all moving in a slow, silent dance. Now, as you lie here, safe and warm in your bed, let your mind drift upward past the roof, past the clouds, and into that quiet expanse. You do not need to be afraid of the size of it. The universe is vast, yes, but it is not separate from you. Think of the legacy that this visitor has left us. It taught us that we are not isolated on a lonely island. We are part of a massive interconnected ecosystem. Just as the oceans on Earth connect the continents, the sea of stars connects the worlds. Imagine for a moment that you can feel the invisible threads that hold everything together. These threads are made of gravity, the gentle hands of the universe. The same gravity that keeps the moons circling the Earth is the same force that guided Atlas on its long journey. It is the same force that is holding you against your mattress right now. You are being held. You are being cradled by the same laws that cradle the suns and the planets. You are grounded, heavy and secure. Breathe in deeply now and imagine you are breathing in the air of the galaxy. Every atom in your body, the calcium in your bones, the iron in your blood, the carbon in your skin was once cooked inside a star billions of years ago. When those stars exploded, they scattered their dust across the darkness. That dust swirled and gathered to form the Earth. It gathered to form the mountains, it gathered to form you. You are not just a person living on a planet, you are the planet. You are the star stuff. You are a piece of the universe that has woken up to look at itself. The traveller Atlas was just a distant cousin, a piece of that same star stuff passing by to say hello. And now that it is gone, you can rest in the knowledge that you belong here. You fit perfectly into this grand design. Let this realization relax your shoulders. Let it unclench your hands. Let it smooth the space between your eyebrows. There is no need to worry about tomorrow or the next day or the problems of the human world. Those things are very small when you look at them from the stars. Up here in the quiet of the cosmos there is only a gentle rhythmic spinning. The Earth spins, the moon spins, the galaxy spins. It is a giant lullaby that has been playing for billions of years and you are rocking gently within its rhythm. As Atlas moves further away, imagine it is carrying away your worries. Picture your stresses as heavy stones that you have placed onto the back of that traveller. Watch them float away, getting smaller and smaller, until they are just tiny specks against the black background. They are gone now. They are no longer yours to carry. The silence of deep space has absorbed them. All that is left is you and the peace of the infinity. You are a citizen of the galaxy. This is your home. The roof of your home is painted with diamonds and swirls of purple and blue nebulae. The floor of your home is the steady, solid earth. You are protected here. The atmosphere wraps around the planet like a thick, fuzzy quilt, keeping the air in, keeping the warmth in, shielding you from the cold. Feel that sense of protection. You are small, yes, but being small means you can be carried. You are a child of the cosmos tucked in for the night. The stars are like nightlights in a long hallway, burning steadily, watching over you with a calm, unblinking gaze. They have seen everything. They have seen empires rise and fall, mountains grow and crumble, and through it all, the peace of the universe remains. That peace is yours now. Allow yourself to sink deeper into the mattress. Your body feels as heavy as a planet anchored by gravity. Your breathing slows down, matching the slow orbit of the traveler as it drifts into the dark. In and out, slow and steady. There is no rush here. In the galaxy, time moves differently. 1,000,000 years is like a single second. There is no deadline, there is no urgency, there is only existence. You exist, you are here, and that is enough. Think of the silence again. It is not a lonely silence, it is a restful silence. It is the sound of a library after all the books have been closed. It is the sound of a house after everyone has gone to sleep. It is a silence that allows you to rest. The story of the traveller has ended, but your story is just pausing for a while. You are drifting now, floating on a calm, dark sea. The waves of sleep are lapping gently against the shores of your mind. You are gained, you are connected, you are home. Good night, citizen of the galaxy. Let the stars stand guard while you sleep. Let the gravity hold you tight. Let the darkness cover you like a soft blanket. Drift away now. Drift into the deep, peaceful, endless night.